Welcome to The Explainer. Have you ever wondered how a hacker can go from knowing basically nothing about your company to owning your entire customer database, and all in just a matter of minutes? Well, today we're going to pull back the curtain on exactly how that happens. We'll follow an attack step by step, and then we'll look at how to build a digital fortress that can actually stand up to it. All right, let's dive in. This quote from security consultant Mike Andrews really hits the nail on the head. At its core, the internet was built to be a library, a place for sharing information freely. It was never meant to be a high-security vault for the entire global economy. And that one simple fact, that's kind of the original sin of web security. It's the reason we're always playing defense.
Okay, so imagine your company's network is this super high-tech fortress. You've got firewalls, alarms, the whole shebang. But here's the thing. Do you even have a website? You have to open a massive gate right in the front wall. That gate is called HTTP. It has to be open. And because of that, security pros have this little inside joke. They call it the Universal Firewall Bypass Protocol. It's a funny way of saying it's a direct tunnel for anyone, and I mean anyone, on the internet to walk right up and start knocking on your application's door.
So this open gate pretty much creates a universal backdoor. And to see what this looks like in the real world, let's follow a little story. We've got two main characters, Sally, who's a startup founder with a brand new app, and Kim, an attacker who's looking for an easy payday. So on one side, you've got Sally. She's just launched her dream, a food delivery startup. She's got her public site where you and I can order food, and then a private, hidden admin panel for her restaurant partners. And then, on the other side, there's Kim. Kim's armed with a toolkit called Kali Linux. It's basically an operating system tailor-made for hacking. He doesn't care about the shiny front door Sally built for her customers. Nope, he's looking for the door she forgot to lock. The very first stage of any real attack is what they call casing the joint. And I want you to forget everything you've seen in the movies with crazy code flying across the screen. Real-world hacks almost never start with some brilliant zero-day exploit. They start with simple, quiet observation, the digital version of a burglar just watching a house for a week to learn its schedule. So where does Kim even begin? Well, first he just needs the server's actual street address on the internet. A simple command, ping, is kind of like looking it up in a digital phone book. And once he has that IP address, he uses a tool called Nmap to scan for open ports. You can think of this like him walking around the entire fortress and just jiggling every single doorknob and window latch he can find, just to see what opens.
And pretty much right away, he gets a hit. Port 80 is wide open. This is the standard universal port for all web traffic. It's the main entrance to the fortress. For Kim, this is a huge confirmation. It tells him the server's online, it's listening, and the welcome mat is out for everybody, and that includes him.
Finding that front door, that was the easy part. Now, Kim gets to his real goal, finding the hidden doors. He's hunting for the pages that Sally never meant for the public to find, like that private admin panel she built for her restaurant partners. See, a normal user, they see the links on the page. Menu, order, contact us. But Kim's looking for what's not linked anywhere. He's hunting for common directories like /admin or maybe some leftover configuration files. And to do this, he uses a tool called GoBuster. Honestly, it's basically an automated battering ram. It takes a massive list of common file and folder names and just tries every single one, hoping to smash its way into a hidden part of the site. And boom! GoBuster gets a hit. It finds a page called admin.php. The server responds with a 200 OK status, which is just the computer's way of saying, yep, that page exists and you're allowed to see it. This is a huge breakthrough for Kim. He's found a secret entrance that has no signs pointing to it anywhere on the public website.
So let's just pause our story for 1 second. What Kim is doing here, this isn't some rare exotic attack. If you look at this chart of the most common web vulnerabilities, you see things like cross-site scripting and SQL injection for sure. But look at those big slices for authentication flaws and misconfiguration. That is exactly the playground Kim is in right now. He's exploiting a forgotten page with weak access control. It happens all the time.
Okay, so Kim has found the door. Now he needs the key. This next step is all about breaking the lock. And this is where all the fancy technology often takes a backseat to one of the oldest, simplest weaknesses in the book, a really, really bad password. Now, Kim could try to guess thousands of passwords for a single username, but that's noisy. It would set off all sorts of alarms and get the account locked. So instead, he uses a much smarter, much quieter technique called password spraying. Instead of trying many passwords on one user, he tries one super common password, like password 123, against many different potential users. It's a slow and low approach that just flies right under the radar of most security systems. But you might be wondering, why do these attacks still work? It usually boils down to a huge mistake in how the passwords are being stored in the first place. This slide shows the wrong way to do it, just saving a password as plain text. The right way is to hash it. A hash is a one-way street, cryptographically speaking. You can turn password123 into a long, random-looking string of gibberish, but you can't turn that gibberish back into password123. It's basically the digital version of putting a document through a shred.
So back to Kim. He fires up another tool to automate his password spraying attack. It starts churning through a list of common usernames and really common passwords. And then he gets a hit. The username? Administrator, a very common default. And the password? I love you. Seriously? One of the weakest, most used passwords on the entire planet. And with that, a single, tiny mistake has just given him the keys to the kingdom.
He logs in. A little welcome message pops up, and right there, sitting below it, is the jackpot, the entire customer database. Names, emails, phone numbers, all of it just sitting there for the taking. The fortress has been breached. Okay, that was the anatomy of an attack. It's a little scary, right? So now let's get to the most important part. How do we defend the fortress? Let's rewind the tape and look at all the different points where Sally could have stopped Kim dead in his tracks. This really gets to the core of good web security. It is all about layers. There is no single magic bullet that fixes everything. You hash your passwords, of course. You verify that a user actually has permission to see the data they're asking for. You treat every single piece of input from a user as if it could be hostile. And look at this one, rate limiting logins. Just blocking an IP address after, say, 5 failed attempts, that one simple fix would have completely shut down Kim's password spraying attack before it even got started.
Now, the good news is you don't have to build all these defenses from scratch. Modern web frameworks have protections for common attacks like SQL injection and cross-site request forgery built right in. And simple things like using HTTPS everywhere to encrypt your traffic, and especially implementing multi-factor authentication, or MFA, these things create powerful barriers that make an attacker's job so much harder.
So here's the big takeaway. Security isn't a product you can just buy or a feature you add at the very end of a project. It's a mindset. It's a continuous process that never really stops. Because every time we build the next amazing thing online, we are also unintentionally creating new ways for it to be broken. And that leaves us with a really crucial final question. As our defenses get smarter to block yesterday's attacks, are we just creating smarter, more complex vulnerabilities for the attackers of tomorrow?